Welcome to week 9 of your stats tutorials. This week we'll be focusing on independent ANOVAs, and this is our first of many weeks where we'll be looking at different versions of ANOVA analyses. Okay, so we are in SPSS, and the first thing we need to do is prepare our data set. So since we're looking at an independent ANOVA, we're going to need two variables. So we're going to need a variable for our independent variable that represents our groups of people, and we need our measure on the dependent variable. So if you recall, the independent variable needs to be at the categorical level, and the dependent variable needs to be measured at the interval or ratio data level. So let's take the example of reaction time. And if you recall, last week with t-tests, we looked at whether reaction time changed in the morning versus the evening. So we had two groups. For this week's example, let's look at whether there's a difference between morning, afternoon, and evening. So let's say for the purposes of this analysis that we have 21 people, so 3 groups of 7. So the first thing I'm going to do is create the independent variable where I make each of my 3 groups. So I can start here, and I have to do so that's my first group, second group, and third group. So to give the details here, we'll say this is our time variable, and if I use the values, 1 will mean morning, 2 will mean afternoon, and 3 will mean evening. Okay, so categorical variable is set up. Now our dependent variable. So I'm going to manipulate it so that we have significant results here. So I'm just going to enter random numbers in, and let's go with, and then okay, so you can see what I did there, but it doesn't matter, it's just an example. So we'll call this one reaction time. Okay, so what we're interested in knowing is whether or not there are differences in the reaction time mean by the time of day groups. So to run this, it's going to be a mean comparison, but we're going to do it in a slightly different way since we're doing an ANOVA this week. So we'll go to Analyze, Compare Means, and this time you're going to select the one-way ANOVA right here. So it's very similar to setup as the t-test from last week. So it's essentially an independent t-test, but with 3 groups or more. So first is our reaction time, which is our dependent variable. We'll put this here. And then the independent variable is time. And this time you'll notice that you don't need to specify which variable equals which group. SPSS will automatically look through this variable and group or make the groups based on the values that you have. So we have a number of different options with ANOVAs, so more options than we did with the t-test. The first is to run contrasts. Now we won't be seeing that in this class, but this would be where you would set up comparisons between different groups if you already have hypotheses about the ways that you think the means will differ. So for example, if you already think that the morning group is going to be different than both the afternoon and evening groups, you could set that up in here. However, for the purpose of this class, we're going to focus only on running those kind of analyses afterwards, so the post hoc analyses. So to do that, we can click here, and right away you can see, that there's a lot of different options here in SPSS for different post hoc analyses, but the ones that we've learned about are, we have Sheffe right here, Tukey, and then the LSD one is there. So since you're doing an SPSS, it's easy to just ask SPSS to do all of them at once, and depending on whether you want to be or have more power or be more sensitive, you can look at which one, but it's not a bad idea to look at all of them to see what's going on. If in the case you have a problem with your variances between groups, you can come back and run it again, and you would want to select the Games Howl option here in order to make a correction in the post-hocs for the unequal variances. And then right here is the option for the significance level that you would want to test with. So we're just going to stick with the default, which is 0.05. So with these 3 selected, we can click OK. And then next in the options, okay, so I'd already selected things here. So we can ask SPSS to give us the descriptive statistics for each group. So what that'll give us is the mean and standard deviation for group 1, group 2, and group 3. So we would like that. We do want the homogeneity of variance test. So if you recall in the t-tests, when we did independent t-tests, SPSS automatically ran the Levene's test, and it was part of the output, and you didn't have to select anything. In the case of ANOVAs, you do have to ask SPSS to run that analysis. So we will click this. And then you have two options here for corrections that can be made to the F statistic if there is a problem with the homogeneity of variance. So for purposes of this class, we'll just select Welch. Okay, so we may not need to look at that, but if there is a problem here, it's not a bad idea to look at that. And then this will give you, if you want, just a plot of the means for all three groups. So I'll just show you what that looks like. You know, visually, if you're a visual person, you might want to see that. And otherwise, we can leave everything else as it is. And then from this point forward, we'll stop clicking the bootstrap option. It does make a difference in terms of how the estimates are done. However, the outputs are going to start to get a lot bigger and bulkier, and by not clicking this, we'll save some space in the outputs. So we won't worry about bootstrapping at this point. So we are prepared to run the analysis, so we can click OK. And the output is going to open, and you'll see that we have a lot of different windows now. So first we have our descriptive statistics. So what this is the dependent variable based on the groups of the independent variable, as well as the grand mean, so the information just on the dependent variable on its own. So if we notice here, right away we can see that the morning has an average reaction time of 3.57, the afternoon is 6, and then the evening is 7.86. And overall, the reaction time for all 21 participants is 5.81. So it's divided by group and this here. And then, of course, we have the rest of the typical descriptive statistics, but we don't need to worry about those right now. So now we have our results of our homogeneity of variance test. So if you recall, last time Levene's test was embedded within another table, but in ANOVA's it has its own table, which personally I think makes a lot more sense. But either way, it can be interpreted the same way as it was last time. So all we're looking for is whether this value here is significant or not. And if you recall, this is the one time where we don't want it to be significant. Okay, we want this to be bigger than 0.05. If it's smaller than 0.05, it means that we do have a problem. However, in this case it's not, so that means that our variances are pretty equal in each group. And if you look up here at the standard deviations, you can see that they're all relatively the same and that you don't have one that's drastically different than the other. And if you did, it would probably show up here and show that you have significant issues with variance, whereas 0.9, that's good, way bigger than 0.05. So we can proceed. Next we have our ANOVA table, which you should be pretty comfortable with right now. And one thing I will just point out to you is that in SPSS, it automatically changes this when you're looking at mean comparisons to say between groups and within groups and total. But you can just continue. It means the same thing as model and error, or model and residual. Okay, it's the same. But between groups is the model variance, within groups is the error variance. So personally, I always mix up between and within and find it much more confusing, so it's a lot easier for me to just focus on error and model. So we can see here that we've got sum of squares model here, sum of squares error there, sum of squares total right here, the degrees of freedom. So if you remember here is the number of participants, sorry, not number of participants, number of groups minus 1, and then this one is equal to the number of participants minus the number of groups. So we have 21 minus 3 gives us 18. And then the mean square model is equal to this divided by this, and the mean square error is that divided by that. And then we have our F ratio, and for these degrees of freedom, an F of 67.9 is much, or has a much smaller probability than 0.005, so we do have significant results and we can reject the null hypothesis. So before we look at where the actual differences lie, we do have this little table here, which in most cases you can ignore. However, if we'd had the issue with homogeneity of variance here, this is where we would read the adjusted values for the ANOVA. So if you can see here, the degrees of freedom in the error term have actually been adjusted. So here we had 18, and in order to account for homogeneity, an issue with homogeneity of variance, if it did occur, we would adjust this value here. And what this would do is it would actually change the value of our F statistic. So it would be this instead of that, and then SPSS calculates whether this new value is significant. So if we had a problem here, you would not want to look at this table, but actually interpret this table here. But in our case, this was not a problem, so we just look at these results. So either way, we do know that our model is predicting more variance than it's not. So that means that we do have a difference somewhere within our means, but we're not exactly sure where. So this is where we would look at our post-hoc tests. And just one quick little side note before we look at the post-hocs. If you did have a problem here with the homogeneity of variance, you would want to go back and run it again and include the post-hoc test for the tests that take into consideration the problem with variances. So in this case we don't need to, but if you did have a problem with variance, you can go back and take a look. Okay, so what we have here are the results of all three tests. So we have Tukey, Sheffe, and LSD. And essentially what we have are the comparisons for each group. So we have morning with afternoon and morning with evening. And we can see here we have the values of the mean differences and the standard error for that mean. But what we're really interested in looking at is this value here. So what we can see is that this difference is considered to be significant. And so if you recall, when you're calculating Tukeys by hand, you determine what is the significant value of Tukeys, or the critical value rather, and if this mean difference exceeds the value that Tukeys requires, you can confirm that you have a significant difference. So in this example, since I purposely made it this way, all of the differences are significant, okay? So whether we use Tukeys or Sheffe or LSD, we see the same thing. Sometimes you might see that there are significant difference on one test and not another, and that's where it comes down to how either strict or non-strict the tests are, and it also depends on just different conditions. So that's where things get a little bit more complicated, but for this class, you can, if your groups are equal, you can pretty much always use Tukey, and if you have unequal groups, then focus on Sheffe results. And then LSD is going to fall kind of somewhere between there. Okay, so significant results everywhere. And then you can actually ignore this last table here. What this does is it just regroups participants based on similar things. So you might find that if you have a case where the morning is different than the afternoon and the morning is different than the evening, but that the evening and the afternoon aren't different, SPSS might actually say you should probably lump your people into a group of 7 and then one big large group of 14. And that actually happens here, but we don't need it. So you can actually even just delete this table outright if it lets me. Okay, it's not letting me, so don't worry about it. Just delete it. And then this is the means plot. So what we have here are each group, so morning, afternoon, and evening. And this is the value of the mean for morning. This is the value of the mean for afternoon. This is the value of the mean for evening. So if you like to look at that visually, you can see. So if you recall, like you might get something like this and something like, completely different depending on the groups you have. It doesn't need to be linear, so we're not worried about whether this is a straight line or not. It's just showing you the group means, and SPSS automatically puts the lines in between, but the lines don't really mean anything important. Okay, so that's it for calculating independent ANOVAs in SPSS, and so you should be able to complete the exercises, and we'll pick up next week with something a little bit more complicated. Thank you.